Now coming to the roadmap that we will be going through in this particular session, we will be starting off by understanding a key concept called relational database. This is the building block for any SQL database that you will be working later on. So a relational database is the first building block that we will uncover, right? So we'll take a look at what relational database means. Then we will understand what is the meaning of entity relationships diagrams, or it is also abbreviated as ERD diagrams. So ERD also stands for entity relationship diagrams. We will uncover the nitty-gritty details behind the ERD diagrams as well. Then we will understand why SQL in the first place. So what is the significance of SQL? What are the different types of databases that implement SQL, right? And we will take a look at installation and setup of one of the very popular SQL tools used throughout the industry called MySQL. So the practice also will incorporate knowledge of MySQL only. So out of all the databases which we will discuss, we will focus our attention towards learning MySQL only. And finally, we will understand some of the very first commands that you can execute using your MySQL workbench. MySQL workbench is nothing but the developer tool that you are allowed to code in, right? So if you are new to programming, you must be knowing that you need a place to write and execute a code, a program, any commands that you have. And that tool which is provided in MySQL is known as MySQL workbench, and that is what we'll be using to practice MySQL as well. So this is the roadmap for today's session, and let's start off with the first road, in this case, the first you can say milestone, which is the relational database. Now, if you take a look at this term relational database, obviously it has two words. First is relational, second one is a database. Now, before understanding what a relational database is, I would first like to talk about what is a database in the first place. So a database is basically nothing but a centralized place wherein you can store your data. And you already might have been using a database every now and then in your day-to-day life as well. A very common example of a database is essentially a hard drive. If you have a mobile phone, the storage in your mobile phone is also a database. Your hard drive on your computers are also a database, right? A database is nothing but a place which is meant to store data, right? That data could be anything. It could be files, it could be images, it could be music, it could be movies, whatever you want. You can store on that particular centralized place, right? Now that is what a database is. Now you might be wondering, okay, this is a database. We understand that. What the hell is a relational database now? So a relational database is a specific type of a database, right? So here the term relational is the key here, right? So this is the key word which is very, very important to understand. A relational database is a database which stores data in format of tables. Now, what is a table? If you have used Excel in your in the past, in your for doing any kind of projects or analyzing some data which you might have downloaded from any website or something like that, you must have observed that all the Excel files that you have, the data is always stored in format of tables, wherein you have columns and you have rows. Right? Data is structured in the format of rows and columns. All right, and each column represents a new feature or a new attribute in your data, and each row represents a new data point of your data. Right, so that is what a relational database stores. Right, as I mentioned previously, your hard disk can store whatever you want to keep. Right, so it can store files, it can store music, it can store PDFs, it can store whatever you want to store on that database. But a relational database is specific to storing data which is stored in the format of tables. So it is meant to only store tables. And what is a table? Table is nothing but a collection of rows and columns. Right, so it's a structured collection of data. So the technical way of defining a table is basically it's a structured collection of data in which data is stored in the format of rows and columns. And some of the examples of relational database are MySQL, which we will practice. Apart from that, there is Oracle DB, Postgres, and a lot more databases which are implementing the principles of SQL. We will take a look at those databases later on as well. So this is what a relational database is. Just to recap, a relational database is a database which is meant to store data which is arranged in a tabular format. A tabular format is a format in which data is present in your rows and columns. Right? So that is what a relational database is, in which the data is present in your format of tables. And how does a relational database work? That is the next question which might come to your mind. So as I mentioned, relational database store data in the format of tables, and these tables basically are interconnected with one another. When we practice, we will take a more deep dive into this particular topic of how these tables are connected with one another. But just to give you a brief overview here, imagine that the tables are having a key, right? So each table has a key column. That key column is the column which can usually use to identify each row of data. Consider that key column as your address in your house, right? So if you're living in any city, we know that each house or each society in that particular city has a unique address. And you can identify any house or any society of that city with the help of that address. Same way, whenever you store information in a table, the information present in a table must have a key column as well. And that key column can be used to identify any row from that entire table. And it is this key column which will allow you later on to establish relationships between two tables in your database. Just to give you a quick example, imagine you are creating a database for an HR department in a company. So whenever you create such a database, obviously you would have one table which will store your employee details. So details like employee name, employee ID. So here employee ID can be treated as the key, right? So employee ID will be your key column that can be used to uniquely identify each employee in that company. So employee ID will be your key. Then you have employee name, employee date of birth, employee department, employees joining date, salary, and whatnot, right? So you would have some demographic information about an employee in a particular table. Now let's say there is another table which is stored in that database, and that table stores information about the projects which are ongoing in that company. So whenever you are storing information about any project in a table, obviously you would have first column would be a project ID, which would help you to uniquely identify any project which is currently being worked on in that company. And a project usually requires employees to work upon itself, right? So these projects would employ some employees that would essentially be implementing that project. Here, the employees would be identified by that employee ID. So this projects table would have a column called employee ID as well. In that employee ID column, you would have IDs of the employees that are working on that project. And then if you want to relate records from the employee table and the projects table, all you need is now that employee ID column from both the tables, right? So you know what employee IDs are working on a particular project. And if you want to gather more information about those employees, then all you need to do is essentially pick those employee IDs which are working on a project, search for those employee IDs in the employee table, and extract the records for those filtered employees, right? So here you can see the tables in a relational database are related to one another as well. That's why we have the word relational coming into picture. So here you establish relations between tables with the help of keys, which we will discuss later on. Don't worry about that. We will go into details about how to establish these relationships formally as well. But here I just wanted to give you an example about how we are actually using the word relational in the relational database, right? So in this case, we can use, and where does SQL come into picture over here? You might be wondering, okay, you understood what relational database is and everything is okay. But now if you talk from the perspective of a programmer is an entity, right? So you are a person who wants to extract data from a database, right? Database is a place. In this case, the database which we are talking about is a relational database, right? So a relational database is storing the data, and you as a programmer want to extract data from that relational database or whatever, right? So you want to manipulate the data, extract it, delete it, or visualize it, or whatever you want to do with that data. It's completely up to you. But the idea here is that you need a way to communicate with the database. All right. So until and unless you have a communication channel with which you can give commands to that database, then you would not be able to work on that underlying data. See, whenever you are working on a particular PC, everything that is being stored inside that PC, you can operate on it by using your mouse, keyboards, and all, right? So you can double click on the file, and the operating system will load the data on that file and will present to you on your monitor, or it will, if you want to do send it across an email, you can do whatever you want to do. Here, the operating system is basically the link between you and the data which is stored on that hard drive. Similarly, for SQL is basically that intermediate which connects you and that database. So if you want to communicate with that relational database, that is, you want to work on the data which is present in that relational database, you want a medium of communication, and that medium of communication is SQL, right? SQL, if you want to know the full form of SQL, the full form of SQL is structured query language, right? Name itself holds the word language, and in this language, what do you have? You have queries. That's why the word query comes into its name, and it's a structured query language, right? So you are using structured queries, and you are using it as a medium of language or a communication with the underlying database, and that's why it gets its name, structured query language. And this is nothing but the interface that allows you to communicate with the data stored in any relational database. Hope this makes it clear that what is a relational database and where SQL comes into picture in this paradigm of relational database. A relational database is basically a centralized place in which you store data in tabular format, and SQL is nothing but the medium of communication. It's the interface which allows you to communicate with the data stored in that relational database. And you will be actually, when we practice it, you will see that we will be looking at a lot many commands, right? So we will take a look at commands which allow you to insert records. We will be looking at commands which allows you to delete records. We'll be looking at commands which will allow you to manipulate the records, aggregate them, and do a bunch of things which you would otherwise have to do manually using Excel. So if anybody has any experience using Excel, you must have found this to be a very tedious process, right? So a couple of disadvantages of Excel which I would like to mention here are that is, in Excel there is always a limitation towards the amount of data which you can load in a file, right? So whenever you have huge files like 100 megabytes or even more, it takes a lot of time to first of all load that data itself in your Excel software, and later on manipulating that data, doing some exercise on top of that data again requires a lot of hard work and a lot of patience first of all, because you need time to allow that system to process those queries in the first place. But what we will later understand is that SQL actually overcomes a lot of those drawbacks of otherwise which you would have to face in any other tabular data software, right? And the commands like join, truncate, insert, update, delete, these are some of the very basic commands which allow you to communicate with your database directly, right? So this is an example on your screen right now, which is an example of how a table would look like. All right. So if you see this example, this table is a table which stores information about employees in a particular organization. So when we talk about employees, as I mentioned previously, you would have a column called employee ID, which will be a unique ID for each employee. Consider it to be like a roll number in a particular classroom. So each classroom has a bunch of students, and each student has been allocated a particular roll number to uniquely identify that student. Same way, if you work for any company, you are always allocated a unique employee ID, which allows company to store your information, which are unique to you. Then obviously you would have a column called name, which would store your name. You would have a column of salary, which would contain your remuneration for that organization. And finally, you would have an age column. Here, we are using a very limited number of columns. Obviously, if you have to design an actual table to store employees' information, you would need to create a lot more columns here, because we are not just storing these simple information. You would also need to store a lot more columns. But since we are just giving an example here, that's why we are limiting our table to have 4 columns and 3 rows. So here, if you take a look at this table here, this table is in a structured format, right? So your data is present in rows and columns format. right? So here these are the columns: employee ID, name, salary, and age. And these here are the rows. The first row contains employee ID 1, whose name is Prerna, salary of 50K, and age of 23. The second row contains employee ID 2, whose name is Urvi, salary of 65 grand, and age of 25. Same way, row 3 contains employee ID 3 with the name of Raj, salary of 37,000, and age of 30 years. All right. So here you can clearly see that data is present in a structured format in rows and columns, wherein columns indicate an attribute and row indicates a new entry or a new data point. All right. Hope this makes it clear. Now, before going forward, I would like to discuss some important terminologies that are there in any relational database. Doesn't matter which relational database you will be working with, right? You will find these terminologies to be present throughout. And what terminologies are we talking about here? So the first terminology that you will be encountering is called attribute. What is an attribute? As I mentioned previously, attributes are nothing but the columns in your tables. So each table will have column, and a synonym of a column is an attribute, right? So you can either address it as a column or you can address it as an attribute. Both of them are correct, right? So for any column in a table, you can address that as an attribute or you can address it as a column. Similar to that, you will have another terminology which is called record. So record is nothing but a row in a table, right? Attribute indicates a column and a record indicates a row, right? So going back to the previous slide here, in this table, we have 4 attributes: employee ID, name, salary, and age. We have 4 attributes in this table, and we have 3 records in this table. The first record is for employee ID 1 with name Prerna, salary 50,000, and age 23. Second record is for employee ID 2 with this detail, and the third record is for employee ID 3 with these details. So we have this table with 4 attributes and 3 records. So these are the first two terminologies: attributes meaning columns, records meaning rows. Then the second term is called a relational schema, or schema, specifically speaking, a schema. So a schema of a table is nothing but, you can think of it like a blueprint of a table. So when we later on practice MySQL, you will find that whenever we create a database, in that database, we will create tables to store the data. Now, when you define any table, during the definition phase, you not only have to specify the name of a table, but you also have to specify what attributes are to be inserted in that table. So like you have to mention, okay, if you are creating this employee table for the first time, you will have to specify the table name, which is employee in this case. Then you will also have to specify what attributes are a part of this table, right? So you will have to specify column name, employee ID, column name, then salary and age. Plus, you would also have to specify the type of values which are getting stored in each column. For example, in this employee ID, we are storing integers, right? So each ID is an integer. In name column, we are storing text type values. So the name for that is called string type values. That is, you are storing textual data. That has another data type. So you have to specify what type of information is getting stored in that column. Similarly, salary also is a number, right? So it can either be a decimal value, because obviously salaries are never specifically integers. There could be some fractional values in a salary column as well. So usually people use decimal type of data type, which allows you to store values even in decimal formats. And finally, age will be an integer. So when you define a schema is nothing but a blueprint of your table. So looking at a schema, you can identify what is the table name, what type of columns are present in that table, what are the names of those columns present in the table, plus what are the constraints which are assigned to each column. So we will take a look at those constraints as well later on, but to just give you a brief overview, constraints are nothing but the checks which you are imposing on each and every column, right? So whatever checks you want to have a mandatory, so whenever you insert any new record in a table, these constraints are nothing but the checks that you need to have mandatorily checked for each and every attribute of that record, right? So let's say you want a constraint that no record should have a blank employee ID, right? So whenever you insert any new record, you want to ensure that no employee ID is left blank. That is, every record must have an employee ID. Another constraint would be that all employee IDs should be always unique, right? Obviously, you don't want your employee IDs to be duplicated. No two employees should have the same employee ID. So that also can be defined as a constraint in this employee ID column, right? So in a schema is nothing but, you can say, think of it like a blueprint of your table, which allows you to look at the information about that table, or what is the metadata about a table: the table name, table columns, column types, and constraints. So primarily, these things are defined in a schema. Then we have degree. Degree is nothing but the total number of columns in your table, or the total number of attributes in your table. So in our case, for the employee table here, we have 4 attributes. So therefore, the degree of this table is 4. So degree is the total number of attributes in a table. Similarly, we have cardinality. Cardinality is nothing but the count of records in your table. So how many total records do you have in a table? That is your cardinality. So in our case, the cardinality for this table is 3. That is, we have 3 rows in this particular table. And last, there is a term called null values. So when do you say a value is a null value? Whenever in a particular table, you find that in some columns, the values are missing. That is, for example, for an employee, let's say you have not, or you forgot to input the salary of a particular employee. Then when you insert that record, the salary will be absent in this record. So therefore, that will appear as a null value in that column. So for employee ID 3, if the salary of that employee ID is not inserted at the time of putting this record in this table, then when you later on print the contents of this table, what you will find is that this record here, which is absent, that is salary of employee ID 3, which is absent, it will appear as null. So whenever you see null written in any particular cell of a table, it means that that particular record is absent from that table, right? So that record is absent from that table. So whenever a value is missing from a table, that missing value will appear as null in that table. Now let's move on to understanding what are the advantages of relational databases. Obviously, if you think from the perspective of what are the benefits that you get, there are a lot of benefits, but primarily we'll be focusing our attention towards these 6 advantages that a relational database has. The first advantage of a relational database is on the security front. All right. So in any relational database that you will use, you will find that these databases have strict security protocols. These protocols will allow you to limit the access of any database to a person. Let's say you find that a database stores a lot of confidential information. Let's say you are working for a company like Amazon, and when the Amazon stores payment related information about any employees, let's say their credit card information or debit card information or login information, obviously you don't want everybody in your organization to get access to that information. You want to have that access restricted to very specific people who actually want to use that information for whatever purposes, right? So that you can perform, that is, you can have strict protocols which will allow you to restrict the access of the tables which are available in the database. And not just tables, you can permit the access to the entire database itself. So you can control, if you are an admin of a database, you can control which people have access to the database in the first place, and then within that database which tables are allowed to be accessed by a particular person, right? So there is a definitive security protocol which is available for you to make advantage of. That is the first advantage. The second advantage is of speed, right? So because it is designed to handle relational data or structured data. So if you know that, okay, you need a database in which you can process structured data very fast, you need a place which allows you to store data quickly, update records, retrieve records, analyze records. All of that can be done very fast using a relational database. So whenever your company is generating a lot of structured data, that is data which is present in the format of rows and columns, and you need a centralized place to store and manage that data, then a relational database should always be your first preference because it is designed to process structured data with extreme speed, right? So it's the speed of execution of queries, inserting queries, deleting queries, running some kind of analytical queries. Everything is pretty fast here. The third benefit is of simplicity. All right. So when you think from the perspective of, okay, how does a relational database compares with the other types of databases? So there are other types of databases as well. So there is NoSQL database, there are graphical database, graph-based databases, and there are much more types of databases which are available as well. There is hierarchical databases as well. But if you compare the working or the inner working of a relational database with the other databases, what you will find is that understanding a relational database is much more simpler because of the structure which it has, right? So the way a relational database is designed, it's pretty intuitive to understand, right? So everybody here must have worked with tables in the past years. So you know what a table looks like, what is the meaning of a column, what is the meaning of a record, what does it mean to retrieve a particular row from another table, right? So all these terminologies will make intuitive sense to you, right? So you don't have to think much in terms of what is happening behind the scenes. So it's pretty simple to understand. The working of a relational database is one of the simplest as compared to the other competitors out there. Then comes the accuracy. Obviously, whenever you work in a relational database, you can be confident that the results that you will get are accurate. Why am I raising this point? Because of the fact that in a relational database, you can impose a lot of constraints on columns, right? So you can specify keys, primary keys, foreign keys, and which will allow you to have mandatory checks on the data which you are inserting in any table. And because of that, the probability of having incorrect information stored in any table becomes zero. And therefore, whenever you run any query or any analytical query on top of that database, you can be confident that the results that you are getting is accurate as long as the query that you have run is correct. Right? So if you are confident that the query which you are writing, that query is correct, then the outcome of that query will also be accurate. It's not like every time you run the query, the results will keep on changing. No, it's not like that. So the results of these queries will be accurate. The fourth or the next point is of accessibility. All right. So in a relational database, unlike in a file-based database wherein you store the data on a remote server somewhere, and then you need to have the IP address and then the location within that server of that particular file. Here, the accessibility of the data is pretty fast. All you need to have is a login information about a server. And once you are logged into any relational database server, right? So if obviously, as I mentioned, in a relational database, first you need to have access to a database, and that access is controlled by your login information. So every user is assigned a login ID and password. And once your login information is correct, then you are given a direct access to the tables which are stored in that database. So the access to the data also becomes pretty easy, right? So you can directly run queries on the tables which are stored in that database. And last is of multi-user. That means that on a single database, you can allow multiple users to work on it parallelly, right? So compare it to another use case wherein, let's say, you don't have a relational database, you have, let's say, an outdated file-based database in which all the information is stored in plain file format. So in that case, if multiple people in your team are working on the same file, then each person will have his or her unique copy of that data. Let's say you have a single CSV file that is getting circulated throughout your team, and anybody who is making changes to that CSV file, that changes will be only visible to that employee or that person who is making those changes, right? So each person in the team will have his or her unique copy of that table, and later on, when everybody is done, you go ahead and try to put together all the changes. It will be a big mess, right? So in apart, the other solution to this problem is what? That allow multiple people to work on the same database, but this time all the changes that will be happening will be in the centralized repository, right? So that multiple people can work on the data which is stored in that table, and all the changes that you are making will be visible to everybody else in your team as well. So these are some of the advantages of using a relational database as compared to other databases which are available for you. And here is a comparison between a flat file database versus a relational database. I have been talking about this a lot. So just to give you a quick overview, a flat file database is nothing but a database like a hard drive or your mobile phones, in which your database is storing the data in file format, right? So CSV files, PDF files, images, music, and whatnot. Obviously, in a flat file database, a benefit is that you are allowed to store a more variety of data, right? So in this case, in a flat file database, you will be allowed to store a much wider type of data. But in this case, it will not be optimized to work with tables, right? So whenever you work or use a flat file database to store a system, you will not get any optimizations that a relational database imposes to you, right? So in a relational database, you know that a database is created to store tables in it, right? So if you have tabular data available, then instead of storing it in a flat file database like your hard disk, it's better to use a relational database which is optimized to store that information, right? So which I mean is that instead of storing data in CSV files or Excel files, which we normally store on your PC, export or import that data to a relational database, right? So take that data from that CSV or Excel file and inject or import that data into a relational database so that now you can use the optimizations of a relational database to work on that data. Hope I have made the distinction clear here. So if you have tabular data, instead of storing it into CSV files, in which you are just storing the data as plain CSV files, if you want to analyze it, then you then have to import it into your tool or whatever program or whatever. Like if you are using Excel, then you have to import it in Excel, or if you are using some other program, then you would have to import it in that and then work on it, which is a big mess. Apart from that, if you have access to a SQL database, then simply import that data into a SQL database, create a table out of it, and then work on that table directly to analyze that data. It will be much more easier and faster for you to use. Right? And in a flat file database, as I mentioned, data is stored in plain text format, right? So if you have a CSV file, that data will be stored in a format of plain text files. Whereas in a relational database, it will be stored in proper tabular format, and each table will have its set of attributes and records, which you can use to later run queries or analysis on top of those tables as well. That's the major difference between a flat file database, which is a hard disk, versus a relational database, for example, MySQL. All right. So now let's move on to understanding entity relationship diagrams. Until now, we have understood what is a relational database, what is it used for, how does SQL come into picture, right? And what are the terminologies around any relational database, right? So these are the few things which we have seen. Plus, we have also seen some comparisons between a flat file database and a relational database. Now we will go a little bit technical here and try to understand what is the meaning of entity relationship diagrams. To get an understanding of entity relationship diagram, take an example wherein you are working in Amazon. Obviously, imagine that Amazon right now is using a relational database to store all types of data which it is generating. So if you think from the perspective of Amazon for a minute, what type of data might be present? So obviously, if you are using Amazon, you know that Amazon has listed a lot of products for selling. So it would have a table which is storing the information about various products which are listed on Amazon. Then you have users which are using Amazon. So it would have a table which is storing information about various people who are registered on Amazon, right? So people like you and me who are going to Amazon for shopping. So it would maintain a table in which it is storing information about ourselves as well, right? So information about me, information about you, right? That would be stored in another table. Then each person is placing orders for various items. So it would have a table which is storing order related information, right? So what is the order ID, what is the order placement date, order total, shipment, and all those information. So it would have a table for that. Then it would have a table which is storing all the transactions which are happening using Amazon, right? So you can think of hundreds and thousands of tables which Amazon is maintaining at any given point of time in that database. Now consider that you are fresher who has just joined Amazon today, and you are asked to get a complete picture of that database. So thinking from your perspective for a minute, imagine the huge burden that would be presented in front of you, because think of the age of Amazon here, right? So amount of time that Amazon has been in existence. Obviously, it might have thousands and thousands of tables which might be available in that database. And if you go and read about each table one by one, you would have to have a lot of patience and a lot of times at your disposal to get a complete picture of that database, which is a big task. And that's where entity relationship diagram comes to your rescue. An ER diagram is basically your blueprint of the entire database now. So in a database, you can have thousands of tables. Now, obviously, keeping record of each table manually will be a big task. So what an ERD diagram does for you, an ERD diagram is a pictorial representation of the tables that are present in any database. So for example, consider that these are the tables or 5 tables which are stored in a database, right? So this is a simple example which is there. An ERD diagram would look something like this only, wherein in that diagram, you will get to know which tables are present in each database, right? So in this case, each block here is representing a table. In that table, you will get information about the table name. You will get information about columns in that table. You will get the information about what are the constraints which are there on those columns, what are the types of values which are getting stored in those columns. Plus, you will also get to know how these tables are connected with other tables in a database, right? So we know that you can say the users table will have a connection to the orders table, because users only are placing those orders. So if you want to know, okay, which user placed a particular order, you need to establish a connection between the users table and an orders table. Similarly, you would have to establish a connection between the products table and an orders table as well, because in an order you are using what is present in an order, a product. So in a orders table, you would know the information about which product are getting placed in that order. So if you want to further have information about those products, then you need to take the product ID for that particular product and search for it in the products table. So you need to have a relation between those two tables as well. And likewise, there could be hundreds of tables which are connected with one another. And in an ERD diagram, you also get to know that information as well. So how two tables are connected with one another, what values are stored in each table, the columns, their types, their constraints, right? And the connections which they are having with the other tables in that database. So that's why I use the term a blueprint. That is, it will give you a overview or a quick understanding of what can you expect in this database, how many tables are there, what are the table names, what are the columns, what are the constraints, what are the types, what are the relations, right? So everything is defined in that entity relationship diagram, right? Just to repeat, an ERD diagram is a pictorial representation of the data which is stored in your database. All right. So now let's talk about why SQL is important in today's day and age. Like we have already talked about the advantages of relational databases. Here, the same advantages extend to SQL as well, because SQL is basically your mode of communication with your relational database. All right. And as I mentioned, SQL is very easy to understand, right? So obviously, the purpose of any language is to be, it needs to be intuitive enough to be understood in the first place. And SQL has been designed in a manner that the commands that you give are pretty intuitive to understand. So if you want to insert some record in a table, SQL has a command called insert. If you want to update some existing records in a table, SQL has a command called update. If you want to delete records from a table, SQL has a command called delete. So you can think that here the commands are pretty intuitive to understand, and that's why it is so easy to learn as well, right? So because of that ease of understanding, the learning phase for a SQL also is pretty small, right? So it's very easy for any fresher to start learning SQL as well, right? And in this case, you get a direct access to the data, right? So by using SQL as a interface, you get direct access to the data which is stored in a database. All you need to do is just write a proper SQL query, and you will be allowed to access the data which is present in that query. Plus, SQL also allows you to audit the data and replicate the data as well. What do we mean by auditing? Auditing simply meaning that you need to check the quality of the data which is stored in any table. So if SQL was not present, what you would have to do, you would have to manually go through each record one by one and try to find out any problems which are present in those tables, which is a very time consuming task. What you can do instead, you can simply run SQL queries which will allow you to check the quality of the data. They will allow you to audit the data. Plus, it will also allow you to replicate your data. For example, let's say you want to migrate the tables which is present in your database to some other database. Right? So let's say you are upgrading your infrastructure and you want to migrate your entire SQL database to a new upgraded infrastructure. So simply what you need to do, you can use SQL to replicate the entire database to some other server as well. So that replication can also be done by using SQL only. Right? You can use it to analyze multiple tables together. So you can actually make use of the relations which you have defined between tables, and you can use those relationships to connect the values between multiple tables at runtime and analyze multiple tables together in one single go. Right? So that's the benefit which SQL enjoys. Right? So in this case, since we already have established relations between all the tables, you know that order ID is linked to the order ID from the user ID is linked to the user ID in the users table. So whenever you want to run any analysis on top of any user, let's say you want to find out for a particular user how many orders have been placed by that user, or what are the average number of orders that the user places every month, or which is the most bought item by that user, things like that, right? So all these questions require you to access data from multiple tables simultaneously, right? So because here you would need to look at the product ID, you would need to look at the user ID, then you would need to look at the product type and do a complete analysis which requires you to pull data from multiple tables together. And SQL will allow you to do that at runtime with extreme ease. You don't have to write a complicated query to run this simple analysis. Right? Plus, it has direct integrations with a lot of visualization tools as well. Right? So what it does is that you have all the data which is stored in any SQL database. You can actually connect it with the front end software, because here you can visualize the data. Right? So it's just like how you have visualization available in Excel as well. Right? So you can convert that chart into a graph as well using Excel. But in case of SQL, those visualizations are not available to you directly. What you need to do is connect SQL to a visualization tool. There are a lot of visualization tools out there. You have Google Analytics, you have Tableau, you have Power BI, and all these tools enjoy a direct connection with MySQL. So you don't have to do a lot of hard work in ingesting data from a SQL database into a dashboard which you have created using some other software. So if you are using any analytical software like Tableau and it requires you to pull data from a SQL database, then you don't have to do a lot of hard work, because Tableau has a direct integration with SQL databases as well. So I hope this advantage of SQL is clear to everyone. Like, so why SQL is important in today's day and age. And this is why actually business choose SQL as well, right? Because of the benefits that we have already discussed, right? So first is of data integrity, right? So no business wants to have incorrect data stored in a database, right? So why would a business use a tool which doesn't ensure data quality? Right? So SQL enjoys that data integrity benefit. That is, you can be sure that the records which are getting inserted, those records are correct without having any inconsistencies whatsoever. That's the first reason. Second is data can be accessed quickly. Obviously, all you need to do is log into the server and you are good to go with the data, right? So you don't have to do a lot of checks. You don't have to do SFTP or whatever you do with other file-based databases to get access to the data in the first place. So data access is pretty fast. Plus, you can control the administrative controls are also given to you. So being an admin, you can control who all have access to the database. The tables which are there in the database, you can even control the access to those tables as well, right? So if you don't want to allow a person to have access to all the tables in that database, you can even do that. That is, you can restrict the access of a person to the content of that database as well. Right? As well as you can share it across multiple people, right? So if you want multiple people to be working on the same database, you can even do that, right? So all these are the benefits that allow businesses to choose SQL over other competitors of SQL. right? And these are some of the key points about the data which is stored in any SQL database, right? So here the data is stored in the tabular format, a very key important point, that a relational database or a SQL database, right? So these two terms are interchangeable. You can either call it a SQL database or a relational database, right? So because all relational databases have SQL like queries to talk to the underlying data. So you can either call it a SQL database or a relational database, it's one and the same thing. But the main point here is that all relational databases will store data in tabular format only, right? And all data in the same column must match in terms of data type. What does it mean? It means that if you have created a column called employee ID, then in that column you can only store employee IDs. You cannot store salary, or you cannot store names, or you cannot store gender in that column. So once a structure for a column has been defined, right? So once you have defined a schema for a table, during the definition time of the schema, you will define what is the column name and what is the type of the value in that column name. Then after that, you will not be allowed to store some other type of values in that column. If you try to do it, you will immediately get an error. Right? So in this case, the type of values in a column must match. You cannot store in an integer column, you cannot store text. In a text column, in a text column, you can store anything because integers can be interpreted as text as well. But here it is not that simple, right? So here you have to be very careful that the values which you are inserting, that all values in a column must match a certain type. And that type is defined during the table creation phase when you define the schema for that table, as I had discussed previously. So when you define the schema, you tell SQL, okay, what type of values can be inserted in that column. And after that, you will not be allowed to change that value. Right? And this consistency is main reason why MySQL ensures data integrity. Right? So if these mandatory checks are not there, then it is very easy for a person to insert a wrong record in a column. Right? So it's pretty normal that a person might accidentally switch the order for name and employee ID. If he does that, then in that case, name would be inserted in employee ID and the employee ID would be inserted in the name column. Right? So this is basically an inconsistency. This is what we were talking about. This is not a correct data. So if you do analysis on such a data, then first you have to ensure that the data checks are proper. Right? And that is the main reason why people use SQL. And talking about what types of databases actually use SQL, so there are different flavors out there, right? So there are a lot of softwares which have been using SQL like databases. So first and the foremost, which we'll be using to practice, is called MySQL. MySQL is not an open source software; it's basically a licensed software which is owned by Microsoft. But people, if you want to practice, they do give a community edition. A community edition is nothing but an open source version of MySQL. In this case, you will be given access to some features of MySQL, and those features would be enough to learn MySQL from the beginning, right? So if you are a beginner in MySQL, then a community edition of MySQL is more than enough to get you started. If you are working in an organization which is using MySQL, then it is very likely that that organization is using a licensed version of that software. Just like how you have Windows nowadays, right? So Windows, people usually buy Windows, right? So you have to purchase this license for Windows from Microsoft, and then only you are allowed to install it on your system. Then you have PostgreSQL. PostgreSQL is an open source implementation of SQL. This is also a SQL database, but unlike MySQL, it is open source in nature. That is, anybody can use all the features of this database, but it is a little bit slower than MySQL. So it is not as good as MySQL. Right? Postgres is also a good software, but it is not as good as MySQL. But the benefit that it enjoys is that it is open source. Open source meaning that nobody has to pay money to get access to that particular software. Right? Anybody who wants, they can download PostgreSQL, all right, and then simply go ahead and use them to store and manipulate the data. The third one is called SQLite. SQLite is another MySQL database, but the benefit here in SQLite is that instead of storing data on a server, it actually stores the tables on your local hard drive in very simple, lightweight files. Right. So what will happen is that in SQLite, your tables will be stored in normal files like CSV files. Right. So it will not store them in complex data structures. Rather, it will use simple file-like objects to store the data. So therefore, when you later plan to migrate that database to some other server, the migration becomes pretty easy because all the data is available in simple text files format. That's the benefit of SQLite, right? So it's a very light. That's why its name gets the name of light, right? So it's not a very memory intensive database, right? So it does not require to have a huge hardware to able to process the data which is stored in there. Then you have Microsoft SQL Server, which is again a SQL database which is owned and developed by Microsoft specifically. Then we have MariaDB. MariaDB is basically an open source clone for MySQL. So as I mentioned previously, MySQL is not available to everyone, right? So all features of MySQL are not available. So that's why creators have created a clone for MySQL and named it as MariaDB. So MariaDB is an open source version of MySQL. And finally, you have Oracle, which is again a MySQL database, which is owned and maintained by Oracle. I think MySQL is owned by Oracle only, not Microsoft. I think earlier I had mentioned Microsoft, but MySQL is also owned by Oracle only, and Oracle Server is yet another database which is owned by Oracle. Right? Yeah, you can see here that in case of MySQL, we'll be using MySQL to do our practice, and in this case, it is built using C and C++. So underlying programming languages which it is written in is basically C and C++. It was open source earlier on, but later on it was acquired by Oracle Corporation. Right? So that's a little bit about MySQL and other types of databases. And talking about the pros and cons of MySQL specifically, so one of the pros of MySQL is that one of the most widely used databases out there, right? And it has a very nice UI which is called MySQL Workbench, which allows you to work with the data which is stored underneath. Plus, it is a very old software. It's like Python, wherein it is present. It has been present for so long that a lot of nice documentation has been presented for that software. So therefore, it is very easy for any beginner to learn that software. So because of heavy availability of learning materials and a huge community, working with MySQL becomes pretty easy. right? And it is very lightweight and portable, right? So here the tables and the way the MySQL is created, it's very lightweight software. It's not like that you need a lot of high-end hardware, right? So you can run MySQL on your local machines as well, right? So you don't need any sophisticated servers to run MySQL. So everything can be done on local community hardware as well. But obviously, if there are pros, there will be cons as well. And some of the cons of MySQL are, first is that it is not scalable, right? So it is scalable, but not that scalable. Meaning, what does it mean? It means that it is not easy to increase or decrease the resources for any MySQL server. Let's say you find that, okay, the amount of storage which is available for that server, it is slowly getting occupied, right? So let's say you had initially planned for a 1 terabyte server to store data using MySQL. But now let's say the entire database is full and you are almost, you don't have any more room to store any new information. Then scaling that server will not be that easy, right? So scaling a particular MySQL server is not that easy. So the scalability is not there in case of MySQL. It is very hard to scale. Plus, it is not strictly following the principles laid down by structured query language. So SQL is in this case, if you read about SQL, what you will find is that the developers of SQL, that is the people who have written the rules for writing the query language. It's obviously every language has some rules which are written. But MySQL actually does not strictly adhere to SQL's regulations and standards. There are some deviation which MySQL has, but those are not those that significant. But yeah, those deviations are still there. So it is not strictly adhering to the SQL's guidelines for writing queries, right? And a lot of the times, NoSQL database becomes a much better alternative for developing scalable solutions. Whenever your organizations require to have an infrastructure which is easily scalable, then NoSQL type databases becomes the first choice for those organizations as well, because no company would want their systems to be non-scalable, because during a course of time obviously you will be keep on generating more and more and more and more data. So ultimately your server will run out of resources, so hence you need scalability in your tools that you are using. And since MySQL is not that scalable, so therefore it might impose some challenges. But if you have a team of developers that can overcome those challenges, then people do have MySQL in the production servers as well. It's not like nobody uses MySQL. People do use MySQL, but then you need to have developers that can work around creating those scalable servers as well. Finally, we will understand how to install MySQL as well. So for installation, there are some prerequisites. Obviously, you would require the MySQL setup software, right? So you need the software to install. Then there are some dependencies which you need to install. No need to worry about installing these dependencies manually, right? So when you work or when you start working, when you install the installer itself will handle the installation of all these dependencies as well. So you need Microsoft.NET framework. You need Visual Studio C++ because you are using a UI as well. So Visual Studio C++, Microsoft.NET, and at least you need 4 gigs of RAM, and 6 to 8 gigs is minimum that you need, because obviously when you are working with any such extensive softwares, you need good enough RAM to work with those. So these are the 2 steps that you have to follow. First, you need to go to the official website of MySQL and you need to download the community edition of this software, right? So there are 2 types of editions that you will find. One is the paid edition, other one is the community edition. You have to go and download the community edition of the MySQL server. And second, just simply unzip the downloaded file and double click to install it for your system. Installation bit is very easy. It's very smooth. You just have to follow the steps which is given in the installer and you will be able to install your MySQL Workbench in your system. So now when you have installed MySQL Workbench in your system, and once the installation is complete, what you will find is that this is what the UI will look like for MySQL Workbench. In this UI, you will get a nice editor which will allow you to write queries and execute queries on your database. On the left hand side of my screen, you can see some of the databases which I have already created in my PC. So I have now currently I have 5 databases over here, right? So as you can see on the left hand side, these are the databases which I currently have, right? And let's say you want to create any new database in your system. Let's see how you can create a new database, right? So in order to create a database, you have a command called create database. Pretty intuitive to understand. You write the 2 keywords create and database, because we are creating a database. That's why it gets its name, create database. Then you give the name of your database, right? So in this case, let's name it new DB, new database, right? So currently I'm just giving a dummy database name. So now what it will do, it will create this database over here. And once your query execution, when you have written this query, you can come up here and click on this execute. So this bold like sign is meant to execute queries. So here there are 2 signs that you can see. The first here, which I'm currently highlighting, this is used to execute queries one by one, right? So in this case, let's say you want to just execute this query which I have written right now, or the query at which the cursor is currently present. So here you can see the cursor is blinking at this query. So wherever the cursor is present, this command will just execute that query. So on clicking it, you can now simply look at the output as well. So at the bottom, you also have the outputs. So here you can see after I ran the query, this was the query that I ran, and it was correctly run because I'm getting a green tick against it. And if you refresh your schemas on the left hand side here, what you will find is now your database is created. So remember, this is the database that we had created, and this database is now available for us to use. This is the first command that I wanted to show, which will allow you to create a database. Now, please remember one thing, that in MySQL, no 2 database can have the same name. That is, let's say now I again go and try to create this database again. That is, now I'm again running this query. Earlier on, I ran this query and then my database was created. But let's say I again want to run the same query. I again want to create a database with the same name. If I try to do that, what you will find is that this time the execution will fail. Here you can see an error is present, right? So you can read this error, which reads, we cannot create a database. New DB database exists. Meaning that there is already a database on your server whose name is new underscore DB. So if you want to avoid such an error, that is, say you are not sure if a database is already present or not, there's a check which you can apply here. So that is called if exists. Right? So in this case, we want to create this database if it does not exist. Sorry, right? So in this case, I already have created this database previously. Right? So in this case here, instead of my query failing, the output here is now a warning. Right? So here you can see three types of signs that you will get in any output. You will either get a green tick, meaning that the execution has completed and the query is completely run. A cross indicates that your query execution has failed and there is an error which has come up. And a warning sign here indicates that there was no error that has come, but there is a warning which is issued to you by your SQL engine. This warning says that it cannot create a database because it is already present. So in this case, your code execution will not fail. The benefit of doing it like this is that if MySQL is not able to perform this step, then it will not break the execution of code here. It will continue to execute the next line of code. In this case, the execution would have failed on this line and the remaining lines would not be executed over here. That's the benefit of getting a warning. So warning is like a simple, and it gives you a check towards, okay, this is what has happened. Kindly address this issue. Right? So it cannot create a database here, but it will not throw an error here. It is just a warning that you will get. Hope it's clear. Then now once you have created a database, then comes the part of using a database to create tables. So obviously on the left hand side, you can see that currently I have 5 or 6 databases right now. If I execute any query right now, right? So I can say, let's say select star from employee. This is a correct query. So if you think about this query, this is a correct query. Right now I'm not explaining about what this query contains. This is just to show a particular behavior of MySQL. So right now this is a proper query without any syntax error. But if I try to run this query, you will see that I will get an error. What is this error which is coming? If you read this error, you will find is that MySQL is saying that you have not selected a database yet. What does it mean? It means that right now I haven't communicated to SQL what database it has to execute a query on. On a server, there could be hundreds of databases that are created. Now, first you have to tell SQL which database do you want to execute your queries. And that is done by specifying the command called use. So in this case, let's say in this case, I want to use a database called company DB, which I've already created. So here you can see there's a database called company DB, which is already created. In this database, there are some tables which are already present. So what am I doing right now? I'm specifying which database to use to execute the query. So here, if I run this, you will now see this query has run. And as soon as the query ran, you will now find on the left-hand side, the company DB database name became bold. So here the name of this database has now become bold, meaning that MySQL is using this database to execute its query. So now once the database is ready to use, if I again run any other query over here, this query will now properly run. And here you can see the output is generated. Right now I'm not explaining the query in detail because this is for another lecture. Just I want to showcase that selecting a database is mandatory. That is, you have to first let MySQL know which database you want to use to execute the queries that you are going to execute in the future. And that is done by using the use command. Use will instruct SQL to use this database to execute any query that is coming in the future. And finally, last query that I want to discuss today is called show databases command. This command is used whenever you want to list all the databases which are created on your server. So if I run this, you will see that in the output, it will list down all the databases that are stored on my system right now. Right? So you have Chinook, Company DB, HRDB, information schema. There are some of the databases which are created by MySQL itself because MySQL also stores a lot of information about a particular, because it's a software. So all the software related information it stores in its own personal schema. So these schemas are created by MySQL only. Apart from that, whatever schemas you personally have created, those schemas will also be present here. Right? So it will list down all the schemas or all the databases which are created on your server that you are working on. So that command is show databases. So whenever you want to show all the databases that are present, that will be done using show databases command. The next command which we want to discuss is called drop command. So just like create was used to create a database, drop is used to delete a database. Let's say you find that, okay, currently you have no further use for a database. Then you can delete a database by calling the drop command. Let's say now you want to drop the new DB that you had created previously. So in this case, this drop database command will allow me to drop a database. I just have to give the name of the database that I want to delete. So if I execute this query now, so now what will happen? You can see that on the left hand side, the database has been deleted. So there is no database present currently, which is of the name new underscore DB. All right. So these are all the queries that I wanted to discuss, and this basically wraps up today's discussion.